Welcome to Data Structures and Algorithms, the Egg Edition. Today's topics: arrays and linked lists. Let's start with arrays. Like an egg box that stores eggs, an array is a data structure which consists of elements that stores values. The elements have an index by which they can be accessed, and they are in a specific order and stored next to each other. Typically, they are all of the same type. In our case, all elements are eggs. If you slice an array, you will get two parts that are again arrays, so an array is a recursive object. How do you execute operations like access, search, inserting, or deleting in an array? As the index of each element maps directly to a particular memory address, accessing the element takes linear time, so the complexity is big O of 1. This is one of the benefits of an array. When searching for an element, you may need to scan the entire array for all n elements, which makes the complexity in worst case big O of n. Inserting and deleting an element is complex, because all indexed elements after the insertion or deletion must change places. Worst case, this could impact all elements in an array, which results in big O of n. Like the fixed number of space in this egg box, an array has also fixed size, no matter if the space is used up to the last seed or totally empty. So the space complexity is big O of n. The fixed size of an array is one of the downsides. Why is it a problem? If you realize during execution that the array size is not big enough, adjusting the size is not possible retrospectively. So, of course, you could try to mitigate that by choosing a bigger array size already at the beginning, but that may waste space if it's not finally needed. In summary, arrays are among the oldest linear data structures and still heavily used, especially if accessing a structure is frequently required. So, for example, for storing a finally written text, and each text line is one array element, or for storing ingredients of a recipe as a separate array element. Let's move on to the next topic, linked lists. Linked lists are also a linear data structure, but with index-free elements where one is linked to the next one. The elements are called nodes, and their order is not given by physical placement in memory. Instead, each element has a pointer, like these surprise eggs have their little surprise capsules with a secret in it. Each pointer represents the address of a location in memory from the next node, so each node stores its own value plus a pointer to the next node, and the pointers are the connections that hold the nodes together. The first node is called head of a list, and a pointer to head of structure is needed. How do you execute operations in a linked list? So for accessing, you need to traverse the list, and you cannot randomly access elements in an easy way because you don't know where they are stored. In case of our surprise eggs, you need to check each secret in the surprise capsule to get a hint about the memory space where eggs are stored. This makes it a big O of n. And also searching must be done iteratively. So in worst case, the complexity is also big O of n. When a new element is inserted, only the pointer of the preceding node must change the address of the new next node, like you would update the secret inside the surprise capsule of this specific one surprise egg only. And a new pointer from the new node to the next node must be edited. And that's it. Traversing the whole list is not required. Change only happens at one position and the rest of the list remains untouched. So only constant time is needed. Changing two pointers is also the required procedure when deleting an element from a linked list, which also means a complexity of big O of 1. Do you see the benefits of simply updating two pointers instead of changing the places of multiple elements? But one thing, do you also see all the surprise capsules next to each surprise egg? This is additional space that is needed for their storage. A linked list with n elements produces a space complexity of big O of n. In summary, linked lists are highly recommended when inserting and deleting elements is frequently required. So for example in apps with an undo button or in web browsers when visited web pages are stored.